All right, part two. I know we've still got people rolling in, but I'm gonna keep going. You can leave it open, it doesn't matter to me. We're gonna do, we did determinative A, we're gonna do determinative B. Max, question.
Determinant is always minus.
Determinative always minus, yes. Max asked a really good question. This is always a minus. If it turned into a plus on the last one because we had two negatives, so that's why it became a plus. Connor?
But I just had a question about the same thing.
Yeah,
On like on the one where it's D by D, how would you build that?
so we would flip it across the line still as well. So if we were to transpose on this one, here's that diagonal, and I just would flip everything in its place. So like these two would switch, the 2 and the 1 would switch, and then that 4 and that negative would switch. So think about the diagonal stays put, everything just kind of reflects over it. Okay. All right, so now I'm gonna do determinative B. So I'm gonna rewrite B just because I don't remember what it is. So I've got 6, 3, 0, -4. And again, we'll do our determinant, we'll do our A times D and our B times C. I'll kind of cancel that and I end up getting -24. We okay with that?
Yeah.
All right. You're supposed to check this. Okay, we're gonna do this. We're gonna come back to the 3x3 determinants in a second, because I do want to show you how to do them by hand, but we'll also do them in the calculator. The reason I had to teach you about determinant is it's gonna help us with the next step. So skip JK and number 3, and we'll just jump down to number 4. Notice all of these have an exponent of -1, -1, -1. Do you remember what an exponent of -1 means? We did flip it when we did just normal algebra equations. What kind of, that's the word I'm looking for, inverse. These are all inverses. So when we had an algebra equation, we flipped the X and the Y and then we solved for that. But these are all finding the inverses. And so we're gonna do a little bit of flipping around, but it's not gonna be just a general flip switch, okay? Again, with my inverses, I can only do this with squares and we'll learn how to do a 2x2 by hand. Only in squares. So if I ask you to do a inverse of a not square matrix, you cannot do that. And then we will know how to do by hand the 2x2s. Inverses uses determinant, which is why I had to just teach you the determinant, okay? With the determinant though, we've got to do a little bit of flipping around, okay? So let me show you the original again. So let's say we have our original matrix is that A, B, C, D. And then we're gonna jump down, we're gonna do the inverse of that. The inverse of that is going to be a new matrix, and we're gonna multiply it by 1 over the determinant. That is your scalar, so we're gonna multiply that 1 over the determinant by every single number in your matrix. Okay? We're also gonna do a little bit of flipping around with our A, B, C's, and D's, okay? A and D are gonna flip spots. So instead of going A and then ending with D, we're gonna start with D and we're gonna end with A. So we're flipping where A and D go. We're gonna keep B and C in their spot, but we're gonna make them negative. So whatever B was, you're gonna switch the sign. Whatever C was, we're gonna switch the sign. My inverse matrix is when I multiply all of this out. All right, so we are gonna go do this now for matrix A. So let's rewrite regular matrix A. Matrix A was 1, -2, 3, and 5. And so we've got to do a couple things. First thing we got to do is the determinant, then we've got to kind of scramble the matrix. Did we already find the determinant for matrix A? 11, good. Why do work twice, right? I'm not gonna redo that. If you want to show yourself, we did the determinant was that 1 times 5 minus 3 times -2. But we just did that right before lunch, so that's 11. So when I do my inverse, I'm gonna go 1/11, and I'm gonna take my new matrix, I'm gonna switch A and D. And I'm gonna make my B and C stay in the same spot, but they're gonna be opposite signs. So instead of -2, it's gonna be +2, and instead of +3, it's gonna be -3. Now distribute, do that scalar multiplication, 1/11 times everything. And I'm gonna urge you, don't use your calculator, we'll just kind of leave it as these ugly fractions. So every single one of these is just gonna be that number over 11, so 5/11, 2/11, -3/11, 1/11. That's your answer, the end. Now, if we were to multiply this by our original matrix, it would cancel out and we'd get what we will learn to be the identity matrix, but that's not a problem for today, okay? So when we cancel it, if we were to multiply them together, it would cancel each other out. It's like dividing by it or subtracting when adding. It's the inverse operation, okay? Why don't you go ahead, try letter B. Try letter B without me for a second. Try letter B without me for a second. I'm here and when you guys. On this one, I did simplify it a little bit because I had some things that I could cancel out. How come the -3 doesn't move? The B and the C, those spots are the same spot, but they become negative. Okay. All right, we're gonna jump back up to the front. I just wanted to use the determinant that we were doing up here. Okay. Now, we're gonna learn how to do the determinant of a 3x3 by hand. I will not ask that of you. It could be like a bonus on something, but this would not be like normal points. I've taught it a longer, more difficult way in the past, but I think that I can teach it maybe a little bit simpler this year, so that's what we're gonna do. We'll make it as simple as possible, okay? So determinant of matrix C. So let's all copy matrix C down, okay? So I've got 1, 0, 1. I've got my sheet next to me, so I have it a little easier than you maybe do. 1, 3, 4, -1, 3, 4, and I'm going just down the column, and then 2, -1, and 0. All right, everyone good with that so far? Okay, when we do the shortcut for this determinant, we're gonna rewrite the first two columns at the back of this. So I'm gonna rewrite the first two columns at the back of our matrix. Okay. If you remember the determinants, we were multiplying like along the diagonal and then minusing along the other diagonal. We're gonna do the same thing here, but we essentially need to like kind of get all of the pieces multiplied by all of the other pieces, if that makes sense. So we're gonna multiply again along the diagonal. So I've got 0 times 1 times 3 times 0. -1 times -1 times 1, and then 2 times 0 times 4. Those are all gonna go together. Okay. I'm just gonna multiply those out and we're gonna end up adding those together. So 1 times 3 times 0 is just 0. -1 times 1, -1 times 1 is +1. And then 2 times 0 times 4 is just 0. So that's all together right there. Okay. Then just like the determinant of a 2 by 2, we're going to minus, and then we're gonna do the sum of the other direction. And so now I'm gonna start in the bottom corner over here and multiply that and that and that together. So 1 times 3 times 2 is gonna be 6. 4 times -1 times 1 is gonna be -4. And then 0 times 0 times 1 is gonna be 0. Now I'm gonna combine my like terms. I'm going to make sure that I did everything right. Okay. I'm gonna combine my terms in my parentheses, so that becomes a 1 minus, and then 6 plus -4 is gonna be 2, right? So I've got 1 minus 2. And then what is 1 minus 2? -1. Good. So that's our determinant. I just added these, and then I added those, and then I minus them. Good, and I did it harder before, and we got -1 as well, so that's good. If we have time at the end of the class, I'll show you how to check it in your calculator, which I think is good practice when we're doing this all by hand, especially on these that are a little complicated. Okay, let's do determinant of letter D, and then we'll do another 3 by 3. All right, what was determinant of D? What was D again? I had D was 2, -1, 3, 5, 1, 4. Can we do the determinant of that? What was one of the rules about our determinants? Has to be a square. Is that a square? Nope. Can we do it determinant? No. You actually don't even need to write that down. The minute you see it's not a square, we just know that that is not possible. Again, I'm trying to show you that no is an okay answer. You're gonna get no sometimes. Okay. Let's go ahead and try number 3. Do you want me to be quiet? You want to try it on your own? Okay, I'll be quiet for a little bit and then I'll help you out. Yes. D is not a square because it is a 2 by 3 matrix, and is that the same number of rows and same number of columns? So square matrix has the same number of rows, same number of columns. All right, go ahead and do the determinant of number 3. I'll show my work on the board if you want to check in. Right, I got my answer for that determinant. Double check your work. Let me know what I can explain. Let me know what questions I can answer. All right. Everybody good? Okay, we're doing so good. The next part, we're gonna actually need our graphing calculators. Do you guys have your little graphing calculators out? Go ahead and get those out and ready. Letter C says we're gonna do the inverse of C on the calculator. Even though we can do the determinant by hand, we're gonna do that in the calculator. We'll try and do D and then we'll do one more little 2x2 practice if we have time. So go ahead and get your calculator out. This is super important for you to know how to plug things in. Okay, this is about to be your new best friend is this graphing calculator. Okay. Let me see. Then find it. Okay. Do you see the word matrix anywhere on your calculator? Yeah, where is it? X. Second, x to the negative one. So the x to the negative one has the word matrix above it in blue. My second button is blue. So to get that matrix, I'm gonna hit my second button and then I'm gonna hit x to the negative one. Okay. Now, these matrices in the very first menu that it's given to me, the names, this is what I'm gonna press when I'm ready to use that matrix. So when I'm gonna do something with matrix A, I'm gonna press enter and it's gonna go back to like my normal calculator view. Now, have we entered any numbers in? No, so this matrix is not what I think it's going to be, so we are not gonna use that. When you go to your matrix menu, in order to put numbers into your matrix, we're gonna go over to edit. So I want you to go all the way to the right to edit, and then you can click on any matrix that you want. We're gonna deal with matrix C on our paper, so if you want that to match in your calculator, you can put it for C, I don't care. I generally am only playing with like A and B. I just am always changing A, I'm always changing B. If I need to use two of them at the same time, I use both A and B. If I need to use three of them, I try and just use those. I try not to store a bunch in, I'm always changing it. So I'm gonna put it in matrix A. I don't care where you put it, just put it in a matrix. To start though, we need to put our dimensions, okay? So we need to do number of rows and number of columns. What was this, the C matrix that we're looking at? It's a what by what? 3 by 3, so I'm gonna press 3, enter, and then 3, enter. And in some way, your calculator should show that you now have like 9 places to put numbers. Okay. Again, your calculators might look different, so if anybody has questions, I'll try to walk around in a second. Now I'm gonna enter all my numbers into this matrix, okay? So I'm gonna go 1, enter, and it goes left to right. So then I'm gonna go -1, 2, 0, 3, -1, and then 1, 4, 0. Now, I double, triple, quadruple, a million time check to make sure that this is right. Because nothing is worse than messing something up or not including a negative and then getting the whole wrong answer. So I'm gonna double check all my rows and columns to make sure that they look like what I want them to look like. Because I promise if you have a question, you probably just mess something up with entering it in. Okay. Now, you're probably done and you're gonna try and press like enter to leave out. You can't just press enter to leave, you're gonna have to actually quit out. So I'm gonna go second mode to quit out of here. Anybody questions for me yet? Okay, now I'm gonna go back to my matrix menu, and now do you see that my matrix A now has a 3 by 3 next to it? Does yours now say 3 by 3 next to wherever you put your matrix? That's helpful so then you know where your things are, okay? So I know that I entered into matrix A, so we're good. I'm gonna press enter. Now I wanna do this matrix raised to the negative first to do my inverse. I'm gonna press negative, X to the negative first button. This looks exactly like what it looks like on my paper. I'm gonna press enter. Yes, Ian.
Yeah, I really again.
Second mode. Second mode puts you out of any screen.
I meant like. How we're in the matrix, how we get to the parentheses added.
Oh, how do I get back here? You get it?
Yeah.
And that is the answer that I got last year, so once you get the answer, you copy it down on your paper where it asks you for it. You figure it out? Let me see, where are we?
So.
And then now we go back to matrix of second, and then now press enter for A. Oversee. And then now press negative one.
Oh, come on, you clicked F6.
He put his C instead of an A, yep. So it's just, you gotta know where you put your matrix at. Okay, let's do the same thing. Can you enter in matrix D into your calculator and then do inverse for matrix D?
I use the restroom.
You may. Now remember, matrix D was all the way over here, so I'm gonna go put him in. And like I said, I like to just always change A, so I just am gonna go edit A again. If you want a new matrix, you can do that. This time I need to make sure it's a 2 by 3. And then I gotta make sure my numbers match. Once your numbers match, press second and then mode to quit out. And then we'll go back matrix and then we'll hit A and then we'll do our -1 again. I got an error message. Did you guys get an error message? It has to be a square. Now, you could have looked at D and been like, it's not a square and just immediately said no and kept moving. But you also could have forgotten that you had to use a square and it would still correct you. It'd still tell you that it says answer matrix power requires matrix 2 by 3 to be a square. So there are wrong dimensions there. All right, turn your paper over. I know this has probably been one of the longest lessons it feels like ever, but there's one more little 2 by 2 matrix over here. Let's see if we can remember how to do that by hand. You may need to flip back to do A and B, or you may just need to remind yourself, if that's my original matrix, this is how to do the inverse. So I'll leave that up on the board for a second if you want to write that down next to number 5, but see if you can do that 2 by 2 by hand. I'm gonna go over here and do this as well. All right, did you guys get the same determinant as I did? Do you guys set up your matrix the same way I did? I'm about to multiply through, but what's 1 over 0 times -8? It's gonna be -8 over 0, and that's an undefined number. That's not a real number, so we cannot do this. This one, there's like no solution, this won't work. Because if all of these were over 0, those are not real numbers. Those are all undefined numbers. So this one, you could do all the right steps, but we'd get down to here and we'd be like, nope, we cannot finish this. Okay. All right, you guys did awesome. I just want this homework the next time I see you in person, which I think is on Tuesday. If it's not on Tuesday, it's on Wednesday. Whenever I see you in person, this is due, okay? I am gonna do a video on 7.3 for you guys to watch on e-learning day. I'm so sorry you guys have an e-learning day, but I will try to get some stuff done without it being too hard and crazy without you with me. I still have time later next week to do more of 7.3, so I won't try and rush it, okay? So just keep a lookout on Schoology for that video, because you are responsible for that by the next time I see you. The end.